Have you ever marveled at the strength and elegance of titanium? This remarkable metal has found its way into everything from aerospace engineering to advanced medical implants and luxury watches. But how exactly is it produced, and what makes it so special? Let's dive into the fascinating industrial journey that transforms raw titanium, or into the versatile material we rely on today. Titanium does not appear in a usable state. It must be extracted from the earth. It is typically found in minerals known as ilmenite and rutile, largely sourced from mines in Australia, South Africa, and Canada. The process begins with heavy machinery extracting the ore, followed by crushing and washing to isolate the titanium-bearing minerals from waste rock. Interestingly, while titanium is the ninth most abundant element in the Earth's crust, it is rarely found in its pure form because it has a strong chemical affinity for oxygen. Separating it from these compounds is a sophisticated multi-step challenge. Once the ore is harvested, the most widely used extraction method is the Kroll process, developed by William J. Kroll in the 1940s. The process begins by converting the ore into titanium tetrachloride, a highly reactive liquid. This involves mixing the ore with chlorine gas and a carbon source, such as coke, and heating it to approximately 10 degrees Celsius in a specialized reactor. At these high temperatures, chlorine reacts with the titanium to form titanium tetrachloride, while impurities are left behind as solids. After distillation to remove final impurities, the titanium tetrachloride is reduced into metallic titanium by reacting it with magnesium or sodium in an inert atmosphere, resulting in a porous, spongy form of the metal. This titanium sponge is far from the finished, gleaming metal we recognize. To become a functional material, it must be refined through methods like vacuum arc remelting or electron beam melting. During this stage, the sponge is often mixed with alloying elements like aluminum or vanadium in a vacuum furnace to remove remaining impurities and create a homogeneous metal. The molten titanium is then cast into large ingots, which serve as the raw material for further manufacturing. These ingots are forged, rolled, or extruded into sheets, rods, or tubes using massive industrial presses and rollers, depending on the final application. One of titanium's greatest strengths is its ability to form high-performance alloys. By introducing small amounts of aluminum or vanadium during the melting phase, engineers can tailor the metal's properties, enhancing its strength-to-weight ratio and corrosion resistance for demanding sectors like aerospace and automotive manufacturing. However, working with this material is notoriously difficult. Due to its extreme hardness and heat resistance, specialized machining tools and techniques are required to shape it without causing damage. Medical-grade titanium, for example, is often polished to a mirror finish to ensure biocompatibility, whereas aerospace components may undergo specific heat treatments to maximize their durability. While titanium is an incredible resource, its production is energy-intensive. However, its long lifespan and recyclability help offset these environmental costs. Many titanium components, such as retired aircraft parts or surgical implants, are recycled, significantly reducing the demand for new raw material extraction. Furthermore, researchers are actively developing more sustainable methods, such as the FFC Cambridge process, which uses electrolysis to extract titanium more efficiently. Though these innovations are still maturing, ultimately, the effort invested in titanium is justified by its exceptional properties. It remains incredibly strong, lightweight, and capable of withstanding extreme temperatures and corrosive environments. From the sleek casing of a luxury watch to the structural integrity of a rocket engine, titanium is truly an irreplaceable asset in modern industry. Its journey from deep within the earth to the cutting-edge technology of tomorrow is a testament to human ingenuity. The next time you encounter a titanium product, take a moment to appreciate the complex, fascinating process that brought it to life. Thank you for watching, and if you have suggestions for our next topic, please share them in the comments below.